Six is, once you are done with this, they'd like for you to take that actual physical model, place this into something like a cardboard box with an axle, okay, drop a follower rod into it, and actually go out there and examine, okay, what's actually happening. And hopefully what you're going to be seeing is you're going to be seeing these measurements, okay, that we got here earlier, okay, according to what our motion graph is saying, and how far, okay, that follower rod is, okay, above the actual box. But there's one very critical piece of information. Do we actually know how tall the actual follower rod is? So another part of the assignment is actually having your kids go out there and actually determining what that actual length of that follower rod is. So this is a very rough illustration or sketch that I created. Okay, we can actually see that this cam is inside the box. The circle is indicating the axle, so we're going to be rotating that axle. The follower rod is coming down through the top of the box, resting on top of the cam. Okay, and the one thing that we have to remember is actually what is the total side distance of your box. So if we were following this with 3.9, we're going to be seeing that that box side is 4.5 inches. We'll just call it 4.5 inches. And now we have to start thinking about what is the information that we know. Okay, so if you remember back to the original problem, it said that the distance, okay, from the top of the box to the top of the follower rod is 2.375 inches. Okay, now we know, okay, that our maximum radial dimension from the center point, okay, of our cam to the very top of the cam is 1.625. Okay, and we can see that, okay, when it's at 180 degrees, and I'll just show it here, at 180 degrees, okay, the very top of the cam, okay, would be coming over, and it is 1.625. So we do know what that distance is. Okay, the other piece of information we know is if this side, the entire side of the box was 4.5 inches, and you have placed this dead center, okay, this actual axle dead center, that distance from the center of the cam to the top of the box would be 2.25. So what is the total length of the follower? Okay, when this is at its maximum, when the cam is at its maximum radial length, okay, we know that that's going to be 2.375. Okay, we also know, okay, that the center of the axle to the top of the box is 2.25. We also know that this distance is 1.625. So if we took 2.25 minus 1.625 and then added the 2.375, the distance for this one, okay, for the total length of the follower rod would be 3 inches. So that's the other part that you have to know. So you would be making your follower rod 3 inches, okay, and then plugging that into the actual box with your physical cam to see if you are seeing the same thing in the motion graph, okay, in the actual physical model of that box assembly with the cam in it. Okay, taking a look at the curriculum, it's asking these 3 questions. So you're going to be evaluating your solution. Okay, does the cam and follower design provide a smooth follower motion when the cam is rotated? Also, is the cam and axle connection sufficient enough to ensure that the cam rotates with the axle without slipping? And finally, does the motion of the follower replicate the motion represented, okay, by the top of the follower motion in the motion graph? Okay, so that is 4.6. It does seem a little bit tricky, okay, but once you kind of see this video tutorial, you're going to see how this entire process works. What we're requiring you to do is basically everything you just saw in this video tutorial, but please also understand that if the motion that you desired was different, this would be the same process in which you use.